Now, so this kind of question here. We have two circles of radii, 5 centimeters and 7 centimeters. They intersect. So if they share a common chord of length 8 centimeters, calculate the common area of the intersection of the two circles. So draw the two circles here. We have the two circles. Draw this circle and this circle here. The area of intersection between the two circles is this. In this case, we can shade this. So let's say this is the center and this center. We can call this center A and this one we call it center B. So therefore join this and this here. Join this and here. So this is 5 centimeters and 7 centimeters. You are told the common chord between the two. Call this one PQ. Let our chord be PQ. PQ is 8 centimeters. This one. This is 8 centimeters. That's the chord. So our chord is 8 centimeters in this case. So there's a chord, 8 centimeters. So therefore, what do you do? So you want to find the area of the common region between the two. And in this case, the common region, I've shaded this common region. I've shaded that common region. So this is 7, this is 5. Also this is 5, this is 7. Now, what you're supposed to do, join the two centers. If you join, the line joining the two centers, when you join these two, this chord bisects this chord. This line joining the two centers bisect the chord. The line from A to B, it bisects this chord. This chord is of length P, from P to Q is 8 centimeters. So therefore, let's say the point of intersection at this point here is X. We can have now something that looks like this. We can have something that looks like this. That is a chord PQ, and this is AB. Let's say it intersects at point X. Let's say it intersects at point X. So if this is 5 and this is 7, then this line joining the two centers bisect the chord. Meaning to bisect it is to cut it into 2. So therefore, this one it is all divided into 2. This is 4 and this is 4 centimeters. So the first step it is to find this angle PAX. Once you find the angle PAX, this angle PAX is equal to angle QAX. So once you find this one, multiply by 2. Count this, the same case. You find angle PBX. Once you find PBX, you already have angle QBX. Then once you get this one, you multiply by 2. So the two, this line joining the two centers is bisect the two angles. The two angles for this. So therefore, let's find this angle. Light Sokotoa here. Light Sokotoa. You don't have, you need this angle theta. You need this angle theta here. You need this angle theta. So this angle theta here, and this is 4. You don't have adjacent. This one is a right angle. You don't have adjacent. So you don't have adjacent anywhere. So you cancel cosine and tan. So what are you using? You are using opposite and hypotenuse. So in this case, we are going to use sine. We want to find the angle. Says at sine beta, because we want to find angle PAX first. Sine beta is equal to opposite 4 all over hypotenuse. So what is 4 divided by 5? So what out to that? 4 divided by 5. So 4 divided by 5. This comes to 0.8. This comes to 0.8. That comes to 0.8. So 5 shift inverse. Press, use your calculator, shift sine. You get 0.8. Your angle is, angle theta there is 53.13 degrees. So therefore, the size of this angle PAX, angle PAX is 53.13. So what is the size of the whole of this angle now? PAQ, which is this one. PAQ. That angle will be twice. So So you say angle PAQ will be 53.13 times 2 times 2. So that angle you get this is 106.3 degrees. 106.3 degrees. That's 106.3 degrees. So you already have got that. You have got that angle. You got that angle in that. Then the next one. You already have that. This inside. So the next angle that you want to get is this angle. PBQ. That's the angle that you want to get. PBQ. So therefore, and it is this one here. You first of all find this angle using second law again. Sine opposite hypotenuse. So you say this angle, what is again theta? Sine theta is equal to opposite 4/7 equals to 4/7. So in this case, you say what is 4 divided by 7? You get 0.57. 0.5714. So if you are using your calculator to find the sine and cosine, you find the sine, you say shift sine, put 0.5714. You get your angle 0.545714. Your angle is 34.85 degrees. 34.85 degrees. So that's what you get that angle. That's 4.85 degrees. Then the next step. What's the next step? The next step in this case is to find angle PBQ because this is PBX. So angle PBQ is twice this angle that you have got here. So it is 34.85 times 2. So that's 4.85 times 2. You get your angle is 69.7. The angle is 69.7 degrees. The angle is 69.7 degrees. Now you have already got the angle PAQ and angle PBQ. You already have those two angles. Agree? So you have that. So then the next thing is now to find the area, the common area between the two. So you have this. You have this one. You have that sector A, P, Q. You find the area of the whole sector. Find the area of the whole sector. You subtract this triangle P, A, Q. So therefore, in this case, you have got this. You have got the area of this segment. So therefore, I want us now to find the area of the shaded region in this case. The area of the shaded region in this case. The area of the shaded region in this case. So you say the angle here, you already got the angle is 106. Area of the triangle 106.3 over 360 times pi. Our pi is 3.142. Radius, this is 5. So you say 5 squared. That's the area of the sector. The area of the sector. Then you subtract the area of this triangle. The area of this triangle, you say minus a half times 5 times 5 times the sine of 106.3. 106.3. So find that. 106.3. So in this case, we will have got the area of this segment. We will have got the area of this segment. So which is this. We have got that. So let's see. 106.3 divided by 360 times 3.142 times 5 squared. So we first of all get 23.19. 23.19. That's the area of this. That's now the area of the sector. Subtract the area of the triangle. The area of the triangle is a half. Is a half times 5 squared times sine of 106.3. So in this case, we get 11.997, which is equivalent to 12. Which is equivalent to 12. So 23.19 minus 12. So 23.19 minus 12. You get your answer is 11.19 centimeters squared. This is segment 1. This is segment 1. Segment 1, you can call it that. Segment 1, which is this. You already have this part. You already have this. So the next thing it is to find now. So once you get that first. Get that one first. So that is how you work it out. Then the next one is to find the next part, is to find this sector here, the area of this sector, minus the area of this triangle. So it looks like this. It looks like this. This is the area that you require to get. So this is 7, and this angle is 69.7. 69.7. So find the area of the shaded. So 69.7 over 360 times 3.142 times r squared, that is 7 squared. That's the area. That's the area of the sector. Subtract what? The area of the triangle. The area of the triangle in this case will be a half times 7 times 7 times sine of 69.7 times 69.7. So you have this area of the sector and the area of the triangle. So you want us to get now that the area of that segment. Now the area of the segment 2 now is the one that you're looking for. So get that. Get that one. You get 69.7 divided by 360 times 3.142 times 7 squared. So the first part you get 29.81. 29.81. We subtract the area of the triangle now. The area of the triangle, in this case, will be a half times 7 squared times sine of 69.7. So this comes to 22.98. 22.98. So you subtract the area of the sector minus the area of the triangle. So for you to get the area of the segment. So 29.81 minus 22.98. So this area comes to 6.83 centimeters squared. So this is segment 2. Segment 2. Segment 2. That's called segment 2. So therefore, to find the area of the shaded region or the common region between the two, in our case, we shaded this point. So therefore, the area of the shaded, the area of the common region is the area of the shaded segment 1 plus area of segment 2. And it will be done. Area of segment 1 plus area of segment 2. Area of segment 1 over area of segment plus the area of segment 2. So work it out. Add 11.19 plus 6.83. 6.83. So 11.19 plus 6.83. And you get this is 18.02 centimeters squared. And this is the common region. Common region between the two circles. It is a common region between the two circles. It is a common region between the two circles. So the required area is that one. So here you must understand the concept of the sine, the cosine, and the tangent. You know which angle do you need to use, or which do you need to use sine, need to use cosine, or do you use tangent. That's the trigonometric ratio that you want to use. So lazima ujue uko na hii 4 na 5. So this is a right angle triangle. So this is opposite hypotenuse. So that one you can only use sine. You can only use sine to work it out like that. So that's how you work it to get it. So once you get this angle, you also get this. Once you get this for private 2. Once you get this angle for private 2, then you have the angle there. The sector angle PAQ, the PBQ. Just that. Once they get there, they get the area of the sector minus the area of the triangle. The area of the sector here, the same sector, the area of the triangle, you subtract them. Then you add the area of the two segments. 11.19 plus 6.83, which equals to 18.02, which is equal to 18.02. And that is how you find the area of the common region between the two uh, circles.